Right guys, today we've got an integration question with two parts from STEP. Now this is my first ever STEP integration question, so wish me luck. Right, so we've got the integral from infinity to 0 f of x squared plus 1 to the half plus x with respect to x equals a half integral from infinity to 1 plus t to the minus 2 ft with respect to t. Now we need to show that these two sides equal each other. So how would we go about this? Well, we can notice that what's within our function here can be written as t. We do this by means of substitution. So we will say t equals x squared plus 1 to the half plus x. Right, so we just write this as t equals root x squared plus 1 plus x. Now, if we evaluate what our two equations really look like, we've got infinity 0, we've got f of t with respect to dx equals a half integral from 1 plus, let's rewrite this as a 1 over t squared f of t dt. Right, so we've got ft on both sides, that's fine. And since we've done substitution, let's look at our bounds. So we've gone from x to t, and we've gone from infinity and 0 from infinity to 1, and yeah, that checks out, that's fine. So essentially what we need to compare now is dx. So let's say we compare this, ft. Cool, so we need to evaluate dfx on the left hand side. On the right hand side we've got half 1 plus 1 over t squared and dt. Let's move this over. Cool. So if we go back up here, we need to find a way to write d of x. So let's start by rearranging for x. So let's square both sides. Actually, just crop this out for now and bring it later. So we've got t squared equals x squared plus 1 plus 2x root x squared plus 1 plus x squared. Well, actually this is a bit extensive, so what we can do instead is bring our single x to one side, and now let's square both sides. Should be hella easier. So we've got minus 2tx plus x squared equals x squared plus 1. X squareds cancel, so we're left with t squared minus 2tx equals 1. Thank God we went about it that way. Right, we said we were rearranging for x, so let's isolate our x. So we've got 2tx equals t squared minus 1, x equals t squared minus 1 half. Right, fine. Now that we've got this, we can indeed differentiate to get us dx. So we've got dx over dt equals a quarter t minus, well, a half is just a constant. Oh, we've made a mistake back here. So if we have, so our mistake was here where we divided by 2t, so we should have t squared over 2t minus 1 over 2t x equals t a half t minus 1 over 2 to the t minus 1 dx over dt equals a half plus a half over 2 to the minus 2, which can be written as dx over dt equals a half plus a half 2t squared. Let's factorize out a half 1 plus 1 over t squared. Now that's all good. And what we can do now is isolate the dx, so we've got a half times 1 plus 1 over t squared times dt. And if we bring in our comparison, voila, we've got what we needed. So we can just get rid of this, and we've proved for part A that all of this equals this. So good start. Now, hence or otherwise show that the integral from infinity to 0 x squared plus 1 to the half plus x all to the minus 3, obviously with respect to x, equals 3 over 8. Right, let's copy our question over to the next page. Right, so honestly, I couldn't differentiate this by looking at this, so let's compare part B to part A. So we've got x squared plus a half plus 1 to the half plus x to the minus 3. Well, here we've got the same here, the same here. The only difference is the minus 3. So we can say f of x equals x to the minus 3, where x is all of this bit here. So if we say f of t equals, where t equals, this reminds us, t equals all of this, ft equals t to the minus 3. And we can use this on the right hand side. So if you rewrite our right hand side, we can say a half the integral of infinity to 1 of all of 1 plus t to the minus t to the minus 3 dt. And let's go ahead and evaluate this. This looks a bit more easier to deal with. Alright, first, before we integrate, let's simplify this expression. So we've got plus t to the minus 5 dt. Right, I think now we're in a position where we are ready to integrate. So we say a half, but we've got an infinity, so we have to say the lim from take the limit from a as a goes to infinity. A half, which took a half there. We've got a1 t to the minus 3 plus t to the 5 dt. Alright, now we can actually go ahead and evaluate our integral. So we've got a half lim as a goes to infinity. We've got, so we add 1 to the power divided by the new power, so we've got minus a half t to the minus 2 plus, or minus a quarter t to the minus 4 from a to 1. Now that's all good. Now we're just on the final step of evaluating. So we've got a half of lim as a goes to infinity. We've got minus a half Oh, before we do this, let's just rewrite our integral as minus this is actually 2 to the minus 4 minus 1 4 2 to the 4 a to 1 got a half lim as a goes to infinity minus 1 2a squared minus 1 over 4a to the 4 minus a half. And now we're evaluating our lower bound, which is minus 1 over 2 minus 1 over 4 times 1 to the 4 is just minus a quarter. So let's quickly evaluate our a's. So we're saying minus 1 over a really large number, which is essentially just 0, minus 1 again over a really large number, 0. So you say all of this is 0. So we've got 0 minus a half multiplied by whatever minus a half minus a quarter is, which is minus 3 over 4. 0 can just go minus a half times minus 3 over 4 is 3 over 8. If you go back up, this is now shown. So good job to me. Hope you like that step integral. It wasn't nice at first, but we persevered through it, and yeah, we made some damn good progress. So see you in the next. Bye bye.